Imagine standing in the middle of a bustling city, surrounded by towering skyscrapers and modern buildings. You feel safe and secure knowing these structures are built to withstand anything nature throws at them. Then, bam, earthquake strikes. What happens when that trust is shattered by an earthquake, leaving destruction and devastation in its wake? Have you ever experienced an earthquake vibrating and shaking everything around you? If so, you would understand what it is like to live without necessities like water and electricity, a life where everything turns awry and haywire. Our understanding of the immovable objects is simply an illusion. They are all grounded in some foundation or platform. Remove the base, and they will crumble right before you. Skyscrapers and buildings are no exception. They can't hold up that high without being grounded. Remove the footing and it's ground zero. To solve this, when the earth moves, the buildings must shift accordingly. Stick to the end to find out how skyscrapers survive the worst of natural disasters. Take what happened in Turkey and Syria recently, where a powerful pair of earthquakes rocked the region and caused the collapse of thousands of buildings. These catastrophic magnitudes of 7.8 and 7.5 earthquakes caused over 20,000 deaths and an estimated $85 billion in destroying properties in these countries. Turkey and Syria share a regional fault line, the world's most seismic active fault zone, making them more vulnerable than any other country. How did we get here? On the 17th of August 1999, a disastrous magnitude 7.6 earthquake hit the Kocaeli province of Turkey, causing massive destruction and over 18,000 deaths. 10 years after the Marmara earthquake, the Turkish government established the Disaster and Emergency Management Authority, AFAD, as a one-stop shop for disaster and emergency management and coordination. This single powerful government institution was to lead in planning and preparation to prevent such casualties in the future. AFAD planned, prepared, and strategized to better respond to earthquake emergencies. These plans were outstanding on paper. The reality is, however, tragic. Fast-paced construction and non-compliance to building regulations eroded the gains. NPR reported in 2017 skyscrapers were built in open-air evacuation zones, making the government's preparations useless. Building to save lives. With these events in sight, how can Turkey, Syria, and other countries build to survive an earthquake? In recent years, natural disasters such as earthquakes have caused significant damage to buildings, infrastructure, and human lives. Building designs that withstand strong tremors has become a top priority for architects and engineers in earthquake-prone regions. These skyscrapers and buildings have proven to save lives and cause less havoc during earthquakes. Building to withstand earthquakes has been a concern for builders and architects for centuries. Throughout history, civilizations have developed various strategies for building structures that can withstand earthquakes' intense shaking and seismic waves. From the ancient Greeks and Romans to modern-day Japan, earthquake-resistant construction has been a vital part of architectural and engineering practices. Concrete jungles. What went wrong? Most concrete buildings crushed in quakes were built without adequate seismic reinforcement. Such structures cannot withstand the lateral forces generated by the upheaval, causing them to fail in a pancake mode of structural collapse. It's a sobering reminder that seismic building codes are a suggestion for earthquake-resistant building design, which has, over the years, saved many lives. As we have already established so far in this video, earthquakes are amongst the most destructive natural disasters, capable of causing widespread damage and loss of life. Therefore, proper planning and construction techniques must be employed in designing buildings that can withstand even the most powerful earthquakes. Ancient Greeks did it. Ancient Greeks were the first to experiment with building structures to withstand earth tremors. Modern engineers and architects have incorporated various technological systems in designing and building shock-proof skyscrapers. While the cost of building an earthquake-resistant facility may be higher than traditional construction methods, the benefits in terms of safety and protection are immeasurable. Governments should mandate using various earthquake-resistant construction techniques and materials in earthquake-prone areas. Specific architectural techniques, if effectively applied, help buildings withstand earthquakes. One such technique is base isolation, where the building's foundation is separated from the ground by shock-absorbing devices. This allows the building to move independently of the ground during an earthquake, significantly reducing the risk of collapsing. The Mexican way. Torre Mayor in Mexico City is an excellent example of earthquake-resistant architecture. This 55-story skyscraper is in a seismically active area and is designed to withstand earthquakes up to an 8.5 magnitude. The building features a base isolation system and state-of-the-art structural engineering, making it one of the most resilient buildings in the world. Moment-resisting frames is another technique engineers have used to fortify skyscrapers. With this technique, towers are designed to flex and bend during an earthquake and still keep their shapes and occupants safe. Though made of steel and concrete, these frames are built to be incredibly strong and ductile, allowing them to absorb and dissipate seismic energy. Let's remember the importance of proper construction techniques. Builders in earthquake-prone regions must use high-quality materials and follow strict building codes to ensure structural integrity. The Asians can teach the rest of the world how it is done. Lessons from Japan. In Japan, for instance, seismic dampers act as superheroes for most skyscrapers by shielding them from the damaging effects of earthquakes. Friction dampers are among the most effective techniques for reducing vibrations during earth tremors. Imagine a massive skyscraper swaying back and forth during an earthquake like a tree in a strong wind. This will be a terrifying experience for anyone. Seismic dampers come in handy in avoiding such fear and panic by using friction's ability to release kinetic energy during an earthquake. Simply put, the framework of the building can swing and bounce with the tremors, while the dampers act as hydraulic shock absorbers dispersing the force. Dampers are not meant to prevent swaying entirely, but to control the oscillations. The safest skyscraper. Though not as famous as Japan or China, Taiwan has one of the most effective earthquake-resistant skyscrapers in the world. Famously called Taipei 101, it is a 1,667 feet tall skyscraper in Taipei, Taiwan. It was the tallest skyscraper in the world when it was commissioned in 2004. Taipei 101 may have lost its artistic title as the tallest building in the world, but it still boasts one of the best earthquake-resistant systems worldwide. It uses its effective internal damper system to deflect swaying and reduce any possible structural failure. This sleek, greenish building is a sight to behold. Don't be fooled by its beauty. It's built to slide and sway when the earth beneath it starts to shake. This clever feature is not only an impressive feat of engineering, but it also ensures the safety of everyone inside during earthquakes and other natural disasters. However, such buildings are too expensive to put up. Cost is one of the biggest obstacles in creating structures that can withstand earthquakes. Building earthquake-resistant skyscrapers, for instance, require unique building materials and construction methods, which can drastically raise project costs. A building constructed to survive an earthquake of magnitude 8.0 would cost up to 30% more than regular construction. However, the truth is, friction dampers are reusable fuses. They are made to activate before the failure of structural parts. Therefore, there is no need to replace dampers after an earthquake because they'll be ready for the next seismic occurrence. Friction dampers can be used to optimize structural components in reducing cost, saving building owners significant money. Therefore, these dampers are efficient, effective, and affordable. Is wood the solution? Wait a minute. What about wood? Mid-rise wood frame buildings can also withstand earthquakes, as demonstrated by the successful test of a 6-story wood frame condominium in Colorado, USA. The test simulated the effects of an earthquake that would occur once every 2,500 years. That's an extreme and rare event. This successful test sparked new hope for safer and taller wood frame buildings in earthquake zones. Can wood be the game changer? Some engineers advocate for changes in building codes that limit construction to 4 stories. They argue that the structural design of wood frame buildings is based on a series of engineered systems that are relatively easy and inexpensive to incorporate. The Colorado Experiment. According to John Vander Lint, the Colorado state engineer who leads the project, the methods applied in the building can be replicated in all structures built in high seismic regions. This could save lives by ensuring that buildings can perform well in earthquakes. Only some agree that wood is a better alternative. They say, wood is not as strong as concrete or steel and will not provide adequate protection during earthquakes. They forget that wood is a renewable resource and a more sustainable building material than concrete or steel. Whatever your opinion is, the 6-story wood frame condominium test is a promise that wood can be used in developing earthquake-resistant buildings. The concept is gaining more popularity due to its sustainability and cost-effectiveness. With further research and development, wood frame buildings could become safer and more reliable for construction in earthquake-prone regions.